All right, what's up, guys? Today's lesson, we're going to start Unit 1, Part 2, okay? And this is Lesson 1, all right? And Lesson 1 is rewriting absolute value functions as piecewise defined functions, okay? So let's look at the absolute value function 2x plus 4 minus 3, okay? It asks us to sketch a graph of f of x using the strategies learned in Algebra 2, finding the vertex and using the slope of each side, okay? So to find the vertex, we have to set what's inside of the absolute value equal to 0 and just solve. Subtract 4 from both sides and then divide by 2. So x is negative 2, so we're going to shift to the left 2. And then we have a minus 3, so that means we're going to shift down. So my vertex is negative 2, negative 3. And so we plot our vertex at negative 2, negative 3. All right, and our slope is 2, so we have to go up 2 over 1 on both sides, because remember, our absolute value functions are shaped as a V. So up 2 over 1, up 2 over 1. All right. Okay, so we're going to come back to this in just a second after we do these next steps, because you'll have a better understanding of where we're coming from. So it says set each expression inside the absolute value of 0 and solve for x. Okay, that's what we just did to find x. So we have to do 2x plus 4 equal to 0, and then solve for x. Subtract 4, and we get 2x is equal to negative 4, and then divide by 2, and x is negative 2, okay? And then it asks us to draw a number line. Draw a number line and divide it into intervals using the values of x found in the previous step, and write the entire equation of the function in each interval, replacing the absolute value bars with parentheses, okay? So here's our number line, all right? And we found x to be negative 2. So I'm going to put negative 2 right here in the middle. And then on the left side, I'm just going to put x being equal to negative 3, and we'll say x being equal to negative 1, 0, 1. It doesn't matter, okay? So now remember, we have to take into consideration when we're dealing with absolute value bars of what is negative and what is positive, okay? So on the left side, we're going to have a negative, okay? And then we're going to drop the absolute value bars and use parentheses. So we're going to have negative 2x plus 4 equal to, 2x minus 4 minus 3. And then we'll have positive 2x plus 4 minus 3, okay? And then we just solve. So distribute the negative signs. We'll have negative 2x minus 4 minus 3. And then I have 2x, 4 minus 3 is positive 1, okay? So here, negative 2x minus 4 minus 7 is just negative 2x minus 7, okay? So now we're going to go back to this right here, and we're going to write the equation for each piece, okay? So the first piece is negative 2x minus 7 when x is less than or equal to negative 2. And then the second piece is 2x plus 1 when x is greater than or equal to negative 2. Okay, and then this piece that I'm highlighting right here is the right side. So this is the equation for 2x plus 1, and the left side is the equation for negative 2x minus 7, okay? All right, we're going to skip part 3, and then we're just going to move into part 4. Okay, it says simplify the equations on each interval by distributing the signs determining in the previous step and combining like terms, then write the equation as a piecewise defined function, okay? So our function is f of x is equal to negative 2x minus 7 when x is less than or equal to negative 2, And our right side is 2x plus 1 when x is greater than or equal to negative 2, okay? So that is our absolute value function written as a piecewise function, okay? And then it says compare your piecewise defined function that you wrote in step 4 above to the equation that you wrote from the graph at the beginning of this exercise. Are they the same? Should they be the same? Yes. Yes, they should be the same equation because both equations represent the same absolute value function, f of x. All right, so now we have the function g of x is equal to the absolute value of x plus 4 plus the absolute value of x minus 1, all right? And so we got to set each expression inside the absolute value equal to 0 and solve for x, okay? So we're going to do x plus 4 equal to 0. Solve for x, you subtract 4, and x is negative 4. And then we have x minus 1 equal to 0. Add 1, x is positive 1, okay? So here we have our number line, okay? And then we have our x values being negative 4 and 1. All right, and to the left of negative 4, we have negative 5. And in between negative 4 and 1, we'll say we have 0. And then to the right of 1, we have x being, we'll say 2, okay? Now, here we have to do the same thing that we did before and drop the parentheses, or drop the absolute value signs and give it parentheses. So we have negative x plus 4, negative x minus 1, okay? Now, we really have to pay attention to our signs here, okay? Now, when we have x being equal to 0, all right, our first sign is going to be positive, and our second sign is going to be negative. And then when x is equal to 2, both signs will be positive, okay? Now, in the first step, we could just go ahead and distribute our negative signs. So we have negative x minus 4 minus x plus 1, okay? And to simplify that, we have negative 2x plus 3, or minus 3, excuse me, to negative 2x minus 3. And we can't simplify anything else here. And then we're going to move on to when x is equal to 0. So we have x minus x, which is 0, and then 4 minus 1, which is 5, okay? So we have negative 2x minus 3, 5, and then let's see what we have here. We have x plus x, which is 2x, and then 4 minus 1, which is positive 3, okay? Skip this third part, and we're going to go ahead and write the equation. Okay, so we have g of x is equal to negative 2x minus 3 for any x value that is less than or equal to negative 4. Okay, and then we have 5 as the second piece when x is between negative 4 and 1. Remember, negative 4 and 1 is what we solve x to be when we drop the absolute value signs and switch it to parentheses, okay? And then the last part, we have 2x plus 3 when x is greater than or equal to positive 1, okay? Now it says graph the function of g of x. Graph the function of g of x, and then determine the domain in the range, all right? So we have when x is negative 4, y is 5, and then it's a negative 2, so we got to go up 2 to to the left 1, up 2 to the left 1. All right? And then it's 5, so it's constant from -4 to 1. So here's 1, so it is constant from here. And then our slope is a +2. So that means we got to go up 2 to the right 1. So up 2 to the right 1. Up 2 to the right 1. And g of x looks like this, okay? So our domain is from -infinity to +infinity, and our range is from 5 to infinity, okay? 5 being a closed interval because we have solid defined points, okay? We have no holes, no asymptotes or anything like that. All right, so now we're just going to do what we've been doing and solve for x and then write the absolute value function as a piecewise function, okay? So our absolute value functions, we have what's inside, x plus 2 and 2x minus 3 equal to 0. And then you could solve x is -2, and here x is 3/2, okay? So we have our number line in 2 intervals with x being -2 and 3/2, all right? And to the left of -2, we'll say x is -3, and between -2 and 3/2, we'll say x is 0, and to the right of 3/2, we'll say x is 2, okay? Now remember, this is the most important part, okay? Your negative signs. When we're on the left side of -2, we have both signs being negative. And then in the middle, our first sign is positive. Our second sign is negative. And then in the right side, it's all positive. Okay? All right. So first thing we could do, just go ahead and mark this off like this, and then we could just distribute our negative signs. So we have -x minus 2 minus 2x plus 3, okay? And to combine like terms, we have -3x plus 1. And then for the middle piece, we have x plus 2 minus 2x plus 3. X minus 2x is -x plus 5. And then we have x plus 2x, which is 3x, 2 minus 3, which is -1, okay? So this is what our new equations are, all right? And then now we're going to write the absolute value function as a piecewise function before we graph. So we have our first piece being -3x plus 1 when x is less than or equal to -2, and then we have -x plus 5 when x is between -2 and 3/2. And the last piece, we have 3x minus 1 when x is greater than 3/2, okay? And so when we graph, when x is -2, y is 7, okay? And then our slope is -3, so we have to go up 3 to the left 1. So up 3 to the left 1, to the up 3 to the left 1, okay? And then we have -x plus 5, -x plus 5. So when x is -2, y is 7. And then when x is -1, well, our slope is -1, so we got to go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, all the way to 1/2 or 3/2. So right about here, all right? And then we have 3x minus 1, so our slope is 3, so we got to go over 1 up 3. But when x is 2, y is 5, and then we could go up 3 over 1, up 3 over 1. And so our function looks like this. All right, last example, we're going to do the same thing, but we gotta make a note right here, okay? So our function is rational. So our function is undefined, whatever makes our denominator 0, okay? So we just set x plus 3 equal to 0 and solve. Subtract 3, and x is equal to 3, okay? So, excuse me, when x is negative 3. So x cannot be negative 3, all right? So we got to take that into consideration here in just a minute, all right? And then we just take whatever's inside the absolute value sign, say equal to 0, and solve. So we have negative x is equal to negative 5. Divide both sides by 1, and x is 5, okay? So here is our absolute value, or our number line. We found x to be 5. To the left of 5, we'll say x is 4. And to the right of 5, we'll say x is 6, okay? And then when, when x is 4, okay, with this being a rational function, our first piece is going to be positive. And our bottom piece is going to be negative, or to the right will be negative. And then solve, we just simplify our rational function. So we have 5 minus x minus 8 over x plus 3, which is negative x minus 3 over x plus 3, okay? And then I'm going to move up here so we have more room. Well, I could factor out a negative sign, so I have negative 1 x plus 3 over x plus 3. Well, this could factor out, so it simplifies down to negative 1, okay? And then here we could distribute the negative signs, so I have negative 5 plus x minus 8 over x plus 3. Simplify that, we get x minus 13 all over x plus 3, okay? And then our function is negative 1 when x is less than 5, but x cannot be negative 3 because it's undefined. And then x minus 13 over x plus 3 when x is greater than or equal to positive 5. And what must be taken in consideration for the function p of x that did not have to be considered before? Well, if it's a rational, we have to take into consideration of what might make this function undefined. Like we did a while ago, we had to set the denominator equal to 0 and find that x value. And at that x value, our function is undefined, okay? So we really have to take into consideration when it's a rational function of that it's not going to be completely defined at a certain x value. You just got to find that x value. And then when you're writing your constraints like we did in the first piece, when x is less than negative 5, but x cannot be equal to negative 3.